This video is to assist in finding the domain for some nonlinear functions that we will encounter early in our course. If you are dealing with a polynomial function, the domain is all real numbers. You can write this with the all real numbers, blackboard boldface style writing as I have here, or you can write that as the interval from negative infinity to positive infinity. When we have expressions that are not polynomials, for instance, rational functions or radical functions, we end up with restrictions on our domain. There's certain values not allowed. But for polynomials, all the values are allowed. As a last statement about polynomials, your function will have some coefficients with powers of x, and those coefficients can be any real number, but the powers of x must be positive integers. Right, so you'll have some sequence of terms added or subtracted, and you end up ending in a constant term. So that's a polynomial. Things like 3x squared plus 2, or something like 6x to the 5th plus 3x cubed minus 1. Those would be two different examples of polynomials, and in both cases, you can plug in any number for x. There are no restrictions. You're allowed to take any real number and raise it to a power, to multiply, to add or subtract. So for non-polynomial functions, like rational functions, we'll call R of x, is made up of two polynomials, where the numerator and denominator of the fraction are polynomials. P of x I'm calling my numerator, and Q of x my denominator. There is a restriction that the denominator polynomial cannot be equal to 0. So in these instances, the domain restriction has to do with that denominator taking on a value of 0. So for example, if we've got a function f of x equal to 6 over x squared, this function is a rational function. The numerator 6 is a polynomial. It's a constant polynomial because it doesn't contain any powers of x other than x to the 0, the constant 6. And the denominator is also a polynomial, x squared. So our domain will be any values of x except for the values where the denominator is 0. So to figure out when does the denominator equal to 0, we can set it equal to 0 and solve. So we take our denominator and set equal to 0. So if I go to solve for x here, I need to take the square root on both sides, and the square root of 0 is 0. So this value, x equals 0, is the one number not allowed to be used for x. So my domain can be represented in interval notation as the values from negative infinity up to 0, but not including it, together with, or union with, 0 to positive infinity, again, not including that value 0. If you're a set builder kind of person for notation, we can talk about the set of x such that x is not equal to 0. And that would also be an accurate way to describe the domain. I have prepared a second example for something rational, because this one, the numerator and denominator polynomials, were relatively small and simple. So let's look at one more rational example. If we're given a function g of x equal to x squared plus 3x minus 4 over x plus 4, we can first note that when the denominator as written is set equal to 0, we get x equals negative 4. So the value negative 4 is not okay for us to use in this function. It will give us a 0 denominator. So my domain will be from negative infinity up to negative 4, but do not include it, together with negative 4 to positive infinity. You can, if asked to graph this type of function, you can simplify the fraction first, looking to see if you can factor the numerator and if anything in common cancels. But the purpose of this video is just to talk about domains. So there is more to be said about these types of functions. It just won't be in this video. The last type of function I want to discuss domain for is square root and radical functions. So in general, before I get to a function with a value of x, in general, with say square root, fourth root, sixth root, those even roots, we can evaluate them when we have a positive number under the radical. Like here, the square root of 16 is 4. If instead we have a negative number under the radical, say square root of negative 25, this is an imaginary number. This is something that is part of the complex imaginary numbers. It is not a part of our study in our course. We're only staying in the real numbers in this class. So the square root of negative 25 is the same as the square root of 25 times the square root of negative 1. I'm allowed to take the negative 25 under the radical and split it using multiplication or division technically. The square root of 25 is 5, and the square root of negative 1 is the imaginary number I. So we get 5i as the square root of negative 25. Again, though, this imaginary number I stuff is not something we're really going to focus on in our course. We stay focused on the real numbers. Now, having this discussion about finding radicals and evaluating, in order to be able to describe how to find the domain of a radical function. So in a radical function, there is a value, a variable x, found in the function. So here's an example. F of x equals the square root of 2x minus 10. As long as the value of 2x minus 10 is bigger than or equal to 0, it's okay. Square root of 0 is 0. Square root of positive numbers are approachable within the real number system. So we need to find, to describe the domain of this function, we need to find what numbers for x will give us a problem, give us a negative number inside the square root. I prefer to first set the expression inside the radical equal to 0 and solve for x so I know what the 0 value is. So I'll add 10 to both sides and then divide by 2 and we get x equals 5. So when we plug in 5 for x, we will have the square root of 0, which is okay. That's allowed. Now, either the numbers for x smaller than 5 or the numbers for x bigger than 5 will give us trouble where we get a negative inside the square root. Typically, I like to think of this kind of with a number line picture. So if this is 5 on my number line, I'm going to choose a point value either larger or smaller than 5 to test out and see if we arrive at negative values. So let's say I choose something smaller than 5. I'm going to go with positive 1. Multiplying by 1 is usually pretty easy. So that'll be a good one. We're going to test that by plugging it in for x and see if there's an issue. So if I plug in positive 1 for x, we're going to have the square root of 2 times 1 minus 10. Multiplying first, that's the square root of 2 minus 10. Then we subtract, we get the square root of negative 8, and that is not a real number, which means it's something we're not allowed to use for x, that value 1. So values on the other side of the number line from 5 will be okay. You can test that, plug in something larger than 5, plug in 100, plug in 10, plug in 7, it doesn't matter. Anything bigger than 5, you will have a positive number after doing the multiplication by 2 and subtraction from 10. So this number line picture shows me a visualization for my domain. I do want to describe this, though, using interval or set builder notation. So I'm including the endpoint 5 all the way to the right forever towards positive infinity. So I am using a square bracket on the 5 to note that it is okay to use that value as well. And then everything to the right forever towards positive infinity.